So in the first part of 5.1, we had really looked at the graphs of quadratics, the vertex, the axis of symmetry, the intercepts. Today we're going to talk about the maxes and mins, and we're going to look at some word problems. So here is where we left off. It says determine the maximum and minimum values of quadratic functions. So both of the quadratics you see in this example are in, remember, that vertex form. So here is our vertex form. Okay? If you recall, your vertex form shows you that A and that H and K. And remember, A determines kind of the width of things. H and K is our vertex. So if we look at the first function they gave us, which is f of x equals x minus 2 squared plus 1, you can clearly see that our HK is the 2, 1 we see right here. And our A value, when you don't see it, your A value is a 1. We could technically put a little 1 there. And if your A value is positive, our quadratic is pointing upward, so you're going to always get a minimum at the vertex. But in the second equation, g of x, we have a negative 1 in front, so our A value is negative 1. So at the vertex of negative 3, 4, we are at a maximum value. Now, you have to be careful. The maximum value of the function is its range value, its y value, 4. That's occurring at an x value of negative 3. So the point negative 3, 4 tells us that negative 3, 4, at an x value of negative 3, I am hitting a maximum height of 4. So you want to think of height. So the maximum or minimum is referring to the height. So remember, if A is positive, it's opening up, and the minimum is going to be K, that y value, that height. If A is negative, it's opening downward, so the maximum is at K. The maximum value is K, that height. So remember, A determines the direction of opening. It might make it skinnier or higher or lower, more stretched or compressed. HK is your vertex. And that's kind of why they call it standard form or vertex form. So let's look at example 5. So it says, I know that's tiny, but you should have a copy you can zoom in if you want to. It says that we're going to try to find the maximum value of a quadratic. It says a backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the fourth. Find a formula for the area enclosed by the fence. If the sides of the fencing are perpendicular to the existing fence, have length L. And then what dimensions should she make her garden to maximize the enclosed area? So if we look at a picture, I can make it a little bigger here. So we're assuming that we've got 80 feet of fence. Okay? So if we take a look at what we know, so this already is enclosed, so we don't need the fence right there. Okay, so we just need 3 sides because that fence was already there in the first place. So if we think about what we know, let's think logically. We're building a rectangular garden, so this is L and this is L. Okay? And if we call that bottom one the width, the W, we know that we had 80 feet, so this would be 80 minus 2L. Okay? Because we have 80 feet to use, we have to take off 2 L's for the 2 sides. Okay? So if we think about the formula for the area is length times width, but we know that the width is 80 minus 2 L's. Okay, because we had a total of 80. We take off 2 L's, and that would be what's left. So let's actually multiply it through so it looks more like a quadratic. So we get 80L minus 2L squared. So we know it's a quadratic because of that L squared. That L squared tells us it's a quadratic. And the front coefficient, the A value, is there. And we can put it in descending order to make it feel more like an A. And you can see that if our A value is negative, then our parabola is pointing downward. And this point right here has to be the maximum value for L, or the maximum area. So the question is what dimension should she make her garden to maximize the enclosed area? And anytime they use the word maximum in relationship to something that's a quadratic, think of vertex. Vertex and maximum will go together. Now, if we maximize it, that happens, the maximum occurs at the vertex. So that means we got to find the vertex. Well, we know how to find the vertex. The vertex is X. In this case, our X's are L's. The vertex is, so instead of XY, let's think of it as LA, where the L is our side length and our A is our area. So our X, or our L, is going to be negative B over 2A. So our A value is right here, negative 2. Our B value is 80. So let's plug it in. So that would be negative 80 over negative 4, or 20. Now, our length of the wire they told us was feet, so our values should be in feet. So the length at which, the X value at which we will get a maximum is 20 feet. Now, that didn't answer what the maximum area is. That's our Y value. So our area, we have to plug 20 in. Just like we found the vertexes before, we found the X. To find the Y, you got to plug it in. So to find the area, we got to plug it in. So that's going to be negative 2 times 20 squared plus 80 times 20. And they did ask what the dimensions are, so I'll get to that in a minute. So if they asked us what is the maximum area, that's going to be 800 square feet. Now that's if they said what is the maximum area is going to be. They did say what is the dimensions of the garden to maximize the enclosed area. So we already know that the length is 20. Remember, the width is 80 minus 2 of the length. So 80 minus 40, 40. So the dimensions, if we answer the question correctly, and that's not how you spell dimensions, maybe it is? Sorry, I can't spell very well. The dimensions, it would be a garden that's 20 feet by 40 feet. Let's talk about the intercepts. Now, we did intercepts in the first chapter, but for quadratics, we just want to really kind of discuss the best methods to take to find them. Now, if you look at the problems up, or the sample quadratics they've given across the top, those parabolas, the first one is an example where there is no x-intercepts. We never cross the x-axis, so that's going to happen. You may recall from an algebra class, do you remember if you did the quadratic formula and you got a negative number inside the square root, there will be no x-intercepts. Next, you might recall, back in Algebra 2, if we hit the x-axis exactly in one spot, so if you have one x-intercept, do you remember the quadratic formula? That square root really determined a lot of stuff. When you took that square root, if you got 0, that's where an indication that you're going to get one x-intercept. And you're going to get 2 x-intercepts like the last one if the quadratic formula, you get a positive number of some sort, any number at all. You're going to hit the x-axis twice. So remember, the zeros are just the x-intercepts. We can find it either by using that quadratic formula, or we can factor it. So like I said earlier, this is where the b squared minus 4ac is less than 0. This one is where the b squared minus 4ac equals 0. And this is where the b squared minus 4ac is greater than 0. Now, that's not super important because I like to try to find the x-intercepts by factoring. That's the most efficient, quickest way to go about it. But if you aren't good at factoring, maybe it's something that's prime and not factorable, or maybe the factorization is just really yucky. You can always solve ax squared plus bx plus c equals 0 by finding the quadratic formulas a, b, and c, and doing that negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the y-intercept is the easy one. You just got to plug in 0, so it's just f of 0. The most, or it will always have 1. You can always, because these are polynomials, these are quadratics, you can plug in 0 no matter what. You will always have a y-intercept of some sort. So no matter what, you always hit it. Like if you look at the problems up above, every single one of those hits the y-axis at a particular value. And that will always happen no matter what. You always have a y-intercept. X-intercepts, you hope you have them, you don't always. But y-intercepts, you will have a y-intercept. So let's go ahead and practice. Let's just find those things and only those things, the y-intercepts and the x-intercepts. The y-intercept is the easy one. Just going to plug in 0. So that's going to be 3 times 0 squared plus 5 times 0 minus 2. If it is in general form like this, it's always the c value. If it's in general form like this, it's always the c value. So if you look at the a, b, and c, our a is 3, our b is 5, our c is -2, it will always end up being the c value. So that's something, a little shortcut there. The x-intercept, you're going to set the function equal to 0. Now that can be solved using the quadratic formula or factoring. We're going to do both. Let's first start out using factoring, because that's an easy way to go. This is a perfect candidate for slide and divide. You remember that? So let's slide the 3 over, and we're going to get x squared plus 5x minus 6, which factors to be x plus 6 and x minus 1. So that's nice if you slide it over and then factor it. Now we slid over a 3. Remember, it's called slide and divide. Slide, factor, and divide. It could even have a little factor word in there. Slide, factor, then divide. So we have to divide that 3 off. If one piece is divisible by 3, divide it. If it isn't divisible by 3, whatever reduced fraction you get, the denominator goes on the x. So this technically factors to be x plus 2 and 3x minus 1. Now, once you get it factored, you're more than halfway there. We just got to split it apart, set each piece equal to 0, and then they become very simple things to solve. And so we get x is -2, 3x is 1, so x is 1/3. And you will see here, in this spot right here, you can also find the answers. You can see them here and here. There's lots of ways to look at it. So we get 2 answers. Now, if we go back to the quadratic equation here, and we try to solve it, our a value is 3, our b value is 5, our c value is -2. So let's plug into the quadratic formula. Let's do the problem one more time. So x is -b plus or minus the square root of b squared minus 4ac all over 2. Now, I will tell you, it's very easy to make mistakes with quadratic formula using order of operations. So I'm going to kind of show you what I do to avoid those mistakes. Okay? So first, the opposite of b. When I see -b, I think of the opposite of b. So I put in -5. And then I do in my brain 5 squared. Most of the time you can do it in your head, or you can throw it into a calculator before you write it down. So 5 squared is 25. And then I usually do the next part in my brain. -4 times a is 3, so that's -12, times c, that's -24, times -1, it become a positive 24, so plus 24. And then all over 2a's, a is 3, so 2a's is 6. So I try to do some of the pieces and parts either in a calculator or in my head, so that as I go through the process, I will make less mistakes with the algebra. And the square root of 25 plus 24, since 25 and 24 combine to give you 49, the square root of that is 7. Let's just do that. So that's -5 plus or minus 7 over 6. Now, -5 plus 7 is 2, so that's 2/6. -5 minus 7 is -12/6. And then when we reduce those down, we get 1/3 or -2. So you better get the same things here and here as you get in the quadratic formula. So both places you get an answer of -2 and 1/3. Unless it specifies, I don't care what you use. If you want to jump right to the quadratic formula and do what you see in red, go for it. If you're good at factoring and you want to do what's in blue, go for it. If it doesn't specify, use the method you want to solve it. Let's look at example 8. It says find the x-intercepts of the quadratic. Okay, so remember the x-intercepts is where the function gets set equal to 0. So we're going to set 2x squared plus 4x minus 4 equal to 0. First, let's approach it through factorization. They are all divisible by 2. So then, once I divide by 2, then I can see, is what's left factorable? Well, the factors of 2 that we see back here on the back always have a difference of 1. 2 is 2 times 1. And when you subtract them, you always get 1. So we're not going to get 2 in the middle. Now, what does that mean? Well, that means that it doesn't factor in a nice way. So in a problem like this, factorization is not a tool that can help me to answer the question. So I must use the quadratic formula. So I'm going to look at this. Now, you can take out the 2 and just use in the quadratic formula what's in parentheses, or you can just put exactly what you see there. They're both going to get you the same thing. One will have more reduced fractions than the other. Okay. So if we just leave it, A is 2, B is 4, C is -4. Or we could use this right here, since everything's divisible by 2. It's up to you. You'll get the same answer. Now remember, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Now, let's plug in. So it's the opposite of b, so that's -4, plus or minus the square root. Now actually do b squared. You know how to do 4 squared in your head, do it. 4 squared is 16. Now we're going to do -4 times the a value of 2, that's -8, times the c value. -8 times -4 is positive 32. And then 2 a's would be 4. So that's -4 plus or minus the square root of 48 over 4. Now, let's think about the number 48 for a minute. It's inside a square root. It's not a perfect square, but I can remove the largest perfect square that's living in there is the number 16. That's 16 times 3. 48 is 16 times 3. So when I think about 48 stuck inside of a square root, just let's think about it as 16 times 3, so that I can remove something. And so I can remove a 4 because the square root of 16 is a 4. Now the 3 is still stuck in there. And now I can reduce, see, when you hear me say the quadratic formula, I always say all over 2a. So it's all over 4. So the only way I can reduce this 4 is if I divide both pieces by 4. So that's really important to know, that you have to divide it in both places. So we get -1 plus or minus the square root of 3. Okay. Now, on a calculator, if you do -1 plus the square root of 3, you get approximately 0.7. Now, I don't want you to do that. I like this answer is perfect. This is what I want. If you do -1 minus the square root of 3, you get -2.7. Okay. Now, where will that show up? Well, the way to check your work in Desmos is if you put the graph in Desmos, you should get X-intercepts. So if you look at this graph right here, you'll see that we hit the x-axis at 0.7 and -2.7. So you can check your work on Desmos very quickly. Throw it into Desmos, tap on the x-intercepts. They should match your algebra. Remember, the algebra and the graphical components should always go together. Now, this last example, and I'm sorry it's so tiny, but is about using the vertex and the x-intercepts in a word problem. So when we were looking at that word problem that had the fencing, and we really wanted to know the vertex was really kind of pointing us in the correct direction. Let's look at this problem. It says a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by this h of t, which is -16t squared plus 80t plus 40. Okay? So the height is in feet, the time is in second. The height is in feet and the time is in second. Now, the question in part A is, when does it reach the maximum height? So that's a time. So the times are like our x's. Maximum, the word maximum tells us we have to use the vertex, but we just need that x, that t, right off the bat. And so where does our vertex happen? -b over 2a. So the t we're looking for in part A is -b over 2a. So if you look, here's our b value of 80. Here's our a value of -16. I just did -b over 2a. Now let's reduce that. Two negatives make a positive. That's good. 32 and 80 can both be reduced a little bit, and that becomes 5/2 or 2.5. Now, please label it when it's just like in our area problem, we labeled it feet or square feet. You want to label what that means. So at 2.5 seconds, we reach the maximum height. Now B, what is the maximum height? Well, that's our h of t. The h of t formula gives us a height. So what's h of t? So we want to know the height at 2.5 seconds. It's part of our vertex. Remember, the x is time, the y is our height. So we got to plug in that time, that 2.5. So if we plug into the formula, -16 times 2.5 squared plus 80 times 2.5 plus 40 is 140. Okay. So that is very much kind of like the problems we did with the fencing. We use that vertex to find information about the maximum height. Now part C is really, when does the ball hit the ground? Well, what would the height be if we're on the ground? 0. So really, this is solving the quadratic or the x-intercepts. So we're really looking at where does -16t squared plus 80t plus 40 equal 0. Now we can do that by factoring, or we can do that by the quadratic formula. You guys decide where you want to go with it. I know they're all divisible by 4, and let's take out that negative. So over here to the side, I'm going to factor out a negative 4. Wonder if I can go any further. Actually, I can. They're all divisible by negative 8. Let's go negative 8. If I factor out a negative 8, I get 2t squared plus 10t. No, I'm factoring on a negative. That would be a negative 10t. I'm sorry. Negative 10t minus 5. Okay. So that is not factorable. So we need to use the quadratic formula. And I'm going to use it on the smaller numbers. So I'm going to solve this part with the quadratic formula. Okay. So we get that t is going to equal. When does it hit the ground? So that's still a time. Okay. Negative b plus or minus the square root of b squared minus 4 times a, which is 2, times c, which is negative 5, is 40. So that's positive 40 over 2a's, which is 4. So that's 10 plus or minus the square root of 140 over 4. Now 140 isn't a perfect square. I'm going to go right into the calculator. The positive answer is going to work. The negative answer will give us a negative time. We're not going to go backwards in time. So we can ignore the minus and just do the plus. So in your calculator, you would want to put 10 plus the square root of 140, hit equals, so you get a number that you can divide by 4. And let's go to the nearest tenth of a second. So that's approximately 5.5 seconds. So if you plug 5.5 into the H formula, you should get 0. Now, because it's irrational, it's this funky decimal, you'll get something real super close to 0. Okay, let's do one more. It says a rock is thrown upward from a top of a 112-foot high cliff overlooking the ocean at a speed of 96 feet per second. The rock's height can be modeled by, I'm going to write it a little e bigger so we can all see it. So it is going to be h of t equals negative 16t squared plus 96t plus 1. So when does it reach the maximum height? So remember, in part A, we are doing negative b over 2a. So in this formula, our a is negative 16, our b is 96. So this is going to be, that's going to be negative 96 over negative 32, which is 3. So that's at 3 seconds, we are going to hit the maximum. But then in part B, they ask, what is the maximum? So remember, you got to plug it in. So if we plug that into our formula, we get, let's see, negative 16 times 3 squared plus 96 times 3 plus 112 is 256 feet. Okay. So those two go pretty quickly. The one that's a little harder is, when does the rock hit the ground? Because the fact is, at that point, we are looking for where is the function equal to 0, the h of t. Now, if you want, you could try to factor it, or if you don't want to waste your time factoring and then not get anywhere, you could just jump right in and try to use the quadratic formula. I will tell you that it is not factorable, but so let's just use the quadratic formula. So we're going to get negative b plus or minus the square root of b squared minus 4 times a times c that's 7,168 over 2a. Now, because I didn't remove the negative, I didn't try to factor it at all, we do have negatives in weird spots. And this time, we would want a negative divided by a negative to get a positive, so we're going to use the negative version. That's one reason I like to sometimes factor it. Okay, so let's do it. So negative 96 minus the square root of 9216 plus 7168 on your calculator, hit equals, then divided by negative 32. And we get something nice. So, and maybe it was factorable. Anyway, you get 7 seconds. So it hits the ground at 7 seconds. So a function equals 0 will get you the x-intercept, and in these word problems, that's where you get the graph. And the assignment that goes with this, remember there is a new textbook in Google Classroom. So you're going to get that book, and you're just working on the odd problems 7 through 45 and then 67 to 73. So there's part 2.